Hi students, today we will study conservative force and non-conservative force. This is the curve showing point A and point B. There are two paths, path 1 and path 2. Let the particle be moved from point A to point B along path first and then along path second. Then work done W1 is equal to integration from A to B along path first f dot dr. Similarly, when particle move along second path, then work done is equal to W2 is equal to integration from A to B along path second f dot dr. These work done W1 and W2 are equal when force is conservative force, and due to the force particle move from point A to B along path first and along path second. Definition of conservative force: a force is called conservative if work done by it on a particle that move from one point to another point depends only on position of these points and not on the path followed. Work done along path first is equal to work done along path second. This is the condition for conservative force. For example, gravity. Example of conservative force is gravity. Another statement for conservative force or definition: if the particle move under the action of force such that total work done during any round trip journey or closed path is equal to 0. Or we say that work done along a closed path is equal to 0, then force is called as a conservative force. This is another curve for conservative and non-conservative force. First curve for conservative force and second curve for non-conservative force. In first curve, there is point A and point B. Particle move from A to B in two ways, that is along pink line. Particle move from A to B, work done is W1. When particle move from A to B through path second, that is green line path, then work done is W2. W1 is equal to W2, then force is conservative force. Another figure for non-conservative force, there is again 2 points A and B. Particle move from A to B along pink path, work done is W1. Particle move from A to B via orange path, work done is W2. In this case, both work done W1 and W2 are not equal, then force is called as non-conservative force. Definition of non-conservative force: a force is called non-conservative if the work done by force on a particle that moves from one point to another point depends on the path followed by a particle between these points. Or if the work done by a force in moving a body over a closed path or during any round trip journey is non-zero, then force is said to be non-conservative. For example, frictional force. Frictional force is non-conservative force. Comparison between conservative force and non-conservative force, or we say difference between conservative and non-conservative force. First difference, work done does not depend on path length in conservative force. Work done depends on path length in non-conservative force. Second difference, work done along a closed path or along round trip is equal to 0 in conservative force. Work done is not equal to 0 along closed path or in round trip in case of non-conservative force. Third difference, conservative force is central in nature. Non-conservative forces are not central. Conservative forces are velocity independent. Non-conservative forces are velocity dependent. Total mechanical energy is conserved at all points and at all times in conservative force, but in non-conservative forces, energy is lost as sound, heat. Work done is recoverable in conservative force, and work done is also recoverable in non-conservative force. This is the difference between conservative force and non-conservative force. Principle of conservation of mechanical energy. We know law of conservation of energy. Law of conservation of energy states that all energy in the universe remains constant. One type of energy or one form of energy is converted into another form of energy. Here we study principle of conservation of mechanical energy. Statement: when only the internal conservative forces does work, total mechanical energy of the system remains constant, that is conserved. Here total mechanical energy, it means sum of kinetic energy and potential energy. Total energy is equal to kinetic energy plus potential energy, that is equal to K plus U, that is equal to constant. This is principle of conservation of mechanical energy. Thank you.